The phone-based approach that we developed relies heavily on machine learning to construct a poverty score for each mobile subscriber, where eligibility is a complex function of how the subscriber uses their phone. Extended data table 3. We also consider an alternative approach that does not use machine learning, but instead simply targets mobile phone subscribers with the lowest mobile phone expenditures. Over the preceding months, methods parsimonious phone expenditure method. We find that this phone expenditure method area under the curve equals 0.57 for rural novice and 0.63 in for the hypothetical national program. Table 1 performs substantially worse than the machine learning based model. Area under the curve equals 0.7 for rural novice and 0.73 for the hypothetical national program. Although the phone expenditure model requires much less data and may be easier to implement, this parsimony increases targeting errors and may also introduce scope for strategic gaming if used repeatedly over time. An important factor in the success of the machine learning model is the fact that it was trained on representative survey data collected immediately before the program's expansion. Since an individual's poverty status can change over time, and since the best phone-based predictors of wealth may also change, a model trained in 1 year or season may not perform well if applied in a different year or season. In Togo, we find that when the machine learning model or the mobile phone data are roughly 18 months out of date, predictive accuracy decreases by 4 to 6%, and precision drops by 10 to 14%. Extended data table 4 and methods. Temporal stability of results. These losses are nearly as large as the gains that phone-based targeting provides over geographic targeting, a finding that underscores the importance of training the model with current representative data. We also compare the phone-based approach to alternative targeting approaches that require a recent and comprehensive social registry. Although the government of Togo did not have such a registry, this comparison helps situate this method relative to other methods commonly used by development researchers and policymakers. These results shown in Table 1 can only be simulated using the National In-Person Survey. Since the phone survey did not collect consumption data, the results are more ambiguous. The phone-based approach, area under the curve equals 0.70 to 0.73, is approximately as accurate as targeting using an asset-based wealth index, area under the curve 0.55 to 0.75, but less accurate than using a poverty probability index, area under the curve equals 0.81, or a perfectly calibrated proxy means test, area under the curve equals 0.85. See methods survey data for the differences between these indices. We note, however, that the performance of the perfectly calibrated proxy means test may substantially overestimate the performance of a real-world proxy means test, which declines steadily over time since calibration. Methods, targeting methods, and counterfactuals.